Distribution of shear intensity over a rectangular section of a beam follows a parabolic curve. If the shear stress in a RCC beam is equal or less than 5 kg per cm square, no shear reinforcement 4 kg per cm square to 20 kg cm square, shear reinforcement provided greater than 20 kg per cm square, size of section is changed. All of the above. In a pre-stressed member, it is advisable to use high-strength concrete and high-tensile steel. In a simply supported slab, alternate bars are curtailed at 1/7 of the span. If L is the effective span of RCC beam, which is subjected to maximum shear Qmax at the ends, the distance from either end over which the shear stirrups are provided is L/2 1 minus 5 Q max. Total pressure on the vertical face of a retaining wall of height h acts parallel to free surface and from the base at a distance of h by 3. In a pre-stressed beam carrying an external load W with a bent tendon having angle of inclination theta and pre-stressed load P, the net downward load at the center is W minus 2P sin theta. If the ratio of long and short span of two-way slab with corners held down is R, Ly by Lx equal to R, the actual reduction of bending moment is R power square divided 1 plus R power 4 times 5 by 6 m. An RCC beam of 25 cm width has a clear span 5 meter and carries UDL 2000 kg per meter inclusive of its self-weight. If the lever arm of the section is 45 cm, the beam is safe in shear. Calculation: shear stress equal to 2000 kg into 5 meter divided by 25 into 60 or 25 into 45. This is in between 4 to 20 kg per cm square or less than 5 kg per cm square. So it is safe in shear. The minimum clear cover for RCC column shall be minimum value is whichever greater. So greater of 25 mm or diameter whichever greater. The maximum shear stress in concrete of reinforcement beam is stress equals to force upon area. Shear force upon area. Shear stress equals to shear force upon width into lever arm. If the length of an intermediate span of continuous slab is 5 meter, the length of the in span is 0.5 meter less than 5 meter. If the tendon is placed at an eccentricity E below the centroidal axis of longitudinal axis of rectangular beam, then the stress at the extreme top edge increases or decreases. It decreases by m by z, moment equals to p load into eccentricity, so pe by z decreases. A foundation is called shallow if its depth is when depth is very greater than the width of the foundation, it is deep foundation. In other cases, it is shallow foundation. If the sides of a slab simply supported on edges and spanning in two directions, the maximum bending moment is multiplied by zero point 0.5, that is 1 by 2 times the bending moment is maximum. A, a T-beam behaves as a rectangular beam of width equal to its flange. Width is equal to its flange if the neutral axis lies within the flange portion, remains within the flange. An RCC beam of 6 meter span is 30 centimeter wide and has lever arm 55 centimeter. It carries UDL and oil level shear stress is 5 kg per cm square. So shear stress equals to 12 into 1000 into 6 divided by 30 into 55. It is less than 5 kg per cm square, or it is greater than 20 kg per cm square. Its value is 40 kg per cm square. So division of the section is needed. A pre-stressed rectangular beam which carries two concentrated loads at L by 3 from either end is provided a bent tendon with tension P so that the central one-third portion of the tendon remains parallel to the longitudinal axis. The maximum deep height is WL by 3P for two loads at either ends. According to the IS 456, slabs span in two directions with corners held down are assumed to be divided in each direction into middle strips and edge strips such that the width of the middle strip is three-fourths of the width of the slab. Middle strip width is equal to three-fourths of the width of the slab. If the permissible compressive stress for concrete in bending C is kg per cm square, kg per cm square, the modular ratio is 280 by 3 sigma c when c is given in Newton per meter mm square, Newton per mm square. Here it is kg per cm square divided by 10 is Newton per mm square. So 280 by 3 c divided by 10 equals to 2800 divided by 3 sigma cbc. In combined footing for two columns carrying unequal load, the maximum hugging bending moment, negative bending moment occurs at maximum bending moment, zero shear force. On pile foundation, the minimum drop is 1.2 meter, 120 centimeter. If bend tendon is required to balance concentrated point load W at the center, the dip must be at least for two loads WL by 3P, for a single load WL by 3P divided by 2 WL by 6P. Here is only WL by 4P. A singly reinforced concrete beam, 25 cm width and 70 cm effective depth, is provided with 18.75 cm square steel. If modular ratio M is 15, the depth of neutral axis is it is calculated by depth of neutral axis XU equals to 0.87 Fy AST divided by 0.36 FCK B, where the modular ratio M equals to 280 by 3 sigma CBC, and here Fy equals to 415 and M25 concrete is used. On calculation, we got the neutral axis depth 300 mm, 30 centimeter. As for IS 456, this will be done at the next session of our video.